Good morning, afternoon, whatever. Good morning. Last day, and I'm happy that you're joining me in such numbers for a talk about FHIRPath. Of course, one of the most exciting parts of the FHIR specification. Well, in fact, it's not part of the FHIR specification, although it's called FHIRPath. It actually works on V2 and on other object models other than FHIR. So if you're looking for FHIRPath in the FHIR specification, you won't find it. It's actually somewhere else. Anyway, I'll be brutally honest. If you saw this talk in Boston, I'm not going to tell you anything new. So if you like to rerun and refresh, that's okay. But if you think, no, I can spend my time better at other, I won't be offended. Right? I'm rerunning the show in Boston because that was the first time I was doing it. So what is FHIRPath? So first off, FHIRPath is not part of the FHIR spec, as I said. So if you want to find the FHIRPath specification, what I do is I go to Google and I do FHIRPath, and then depending on the version of FHIRPath you want, I do FHIRPath DSG1 or FHIRPath normative. So if you Google that, you get to the FHIRPath specification. So FHIRPath is versioned separately from the FHIR spec too. That is interesting. Ooh, well, whatever. Stay off. So the current FHIRPath that we're using and it's built into all the software is FHIRPath STU1. So that's totally separate from FHIR DSTU4 or 3, but we keep it compatible. So luckily, these are two separate specifications. I think that's important to realize. But we use it quite a lot, and your origins of FHIRPath are actually stemming from FHIR. But when we presented it for the first time in the workgroup meetings, people were saying, "This is so useful. Can we use this beyond FHIR?" And said, "Yeah, why not?" So we did it in a separate specification. So FHIRPath is, as the specification says, a path-based navigation and extraction language. And it's much like XPath. I think it says that too there. And so what is that? A navigation and extraction language. It's a little language we created ourselves that helps us in these use cases here. So many places in the FHIR specification, again, where this originated from, we felt the need to point to somewhere in an instance of data and say, look at that point and then do something. So what's that do something? Well, navigate to a point, for example, and we use that to define new search parameters. We all know that if you're looking up a patient on the FHIR REST endpoint, you can look it up by name. But all these search parameters, like name, they are defined using FHIRPath. Because we say, this is the field you should be indexing for this search field. So how do we do that? You need to point somewhere and say, I want you to index patient.name. That's that's a natural thing, patient.name. Index that for me. So it's a navigation language in that sense. Another use for it is when we want to formulate constraints. I don't know if many of you watched my tutorial yesterday on structure definition. Structure definition is one way to create constraints on FHIR data, but that's about cardinalities and vocab and so on. FHIRPath allows you, because it's a little language, to do all kinds of things like, I want all my names to start with the letter K. It's totally silly, but you could do that using FHIRPath. So in structure definition, you can formulate additional constraints using FHIRPath. So this way you can also create validations that add up stuff and say, the total sum of this score should be 10, otherwise it's not valid. That's the kind of things you can do with FHIRPath as well. And then you can go all wild and say, well, now I have an extraction language. Why don't I use it to define exactly how I want to turn structured data into narrative? Because you can say, take this part, concatenate it with that, and so on, and create a patient label. You can go out. There's all kinds of things you can do with FHIRPath. One thing I want to tell you that's not here is that we based FHIRPath on many things that were there already. XPath is, kind of inspired us, but maybe deterred us rather than inspired us. XPath, we thought was rather complex, and it's bound to XML technology, and FHIRPath works on both models, both JSON and XML. So I have that picture here. What are we navigating? We are navigating FHIR data, but some FHIR data is in XML, and some FHIR data is in JSON. So what we did is we defined a model that abstracts away from the real syntax. And that is what you're navigating in FHIRPath. So that thing on the right here, that tree, that is the logical model behind FHIRPath. So here, here's the XML version. You see in XML, of course, some things turn into attributes, some things are elements. You have a root element that actually indicates the type of the stuff. All of that is not available in JSON, or it's done differently in JSON. In JSON, you have this field called resource type to indicate the type. But as you can see, both of these appearances, syntaxes, they both map to the same tree. So there's this abstract tree with a root, and then here in italics is the type of each node. So FHIRPath is type aware. So when you're loading instance data into such a tree, mentally or physically, if you're running a FHIRPath validator or a FHIRPath runner, it gets into that tree. You have a name here, a type, and you can see that the primitive values, like my name, Kramer, Wouter, Gert, they end up as, in red there, as values in FHIRPath. So that's step one. Now what you want to do is navigate down this tree. The obvious thing to do, of course, is to use the dot. One more. So we can navigate by name through the tree. There we go. So patient.name.given, that's the most natural way to navigate through a tree. There is a tricky bit though, and this, if you're used to XPath, you will have fallen in this trap before. So we start at patient, which is the root, then we go down to name, but there are two names, right? There are two names called node, and then if we step down into given, that means that we're not only stepping down into the given nodes of that first name node, but if that second name node there would have givens too, that would have been included in our selection. You know, we're walking the tree, and so not only that red box would have the givens from that other name too. That is, a usual trap that I fell into in XPath, and we thought it would be nice if we gave you the opportunity to fall into the same trap with FHIRPath. There's no other way to do it. You can also say name.given. That would work on anything, even if it's not a patient. A polymorphic matching kind of. Just like XPath, we can match by axis, by child axis. So patient.children will give you all the children, all the direct children of a patient, and descendants will give you the whole tree there. And you can combine those things. So you can say, go to the descendants, and you have this long list of all nodes that are there in your instance, in your actual patient instance, or use, family given, and so on, and then filter all those on use. And so there's only one left after I've navigated down that path. There's other ways too. So let's see. We can navigate by position. If you're really sure what the position is. And I don't think that happens a lot, but you could do it. So we're zero-based. That's the only reason why I'm showing you this. Patient.name1 is selecting the second name. Depending on your language background, that might freak you out or feel totally natural there. And then we have last and first. So if you're if you're used to any kind of these link in .NET or any of these jQuery or whatever Haskell, we all have these kind of collection operators or functions. So patient.name.last, that must be this one here. Okay, and then of the list of givens, those are two, give me the first. We're always working with lists here, as you can see. Subsets, patient.name.given. Now that's an interesting one. So this is exactly showing what I tried to tell you before. If name, patient.name selects both of these names here, and multiple of these, or all the names there, all three of them, all have givens. So that would actually select that whole list as a result of the navigation. Tail, it should be with a small t, by the way. Patient.name.given.tail would have all the givens except for the first one. And there's, you use skip intakes. So get that list, skip the first, we have a smaller list, and then take 3 from those. That would select you these ones. So that's fun. We can walk through a tree now. That's step 1. There's probably things you want to do with those too. Now I have that list. What am I going to do with it? Well, if you're extracting data, you're mostly done. So I've been using the word list a few times. If you select this, it's a list. And then definitely if some field repeats, it feels like a list. And if you're doing descendants, it feels like a list. But not everything we know, we know the FHIR model, we know that patient.active only has 1 occurrence. Is that a list too? Well, in FHIRPath it is. Everything is a list. So if I go to patient.active, I get a list of one thing, patient.active, but it's still a list. Patient.name.count and patient.active.count in that way makes sense in FHIRPath, even though you know that name or active has a cardinality of 0 to 1 and name has a cardinality of 0 to star, you can still count them. It doesn't really, we don't make that difference. There's no need for it to do that. So you can even say silly things like, well, name.first is okay, but you could easily do patient.active.first.count, even if that doesn't seem to make sense. And in some ways, you don't know. If you have a profile that constrains something to only 1, you're sure there can be only 1. But if one profile set to 0 to star, you don't know. So we're not making that distinction here. We're lists, period. Patient.active to first, there you go. This is a nice one too. 3.count. What happens here? Even constants in FHIRPath are a list. So this would return you 1, because that's a list with one thing, the integer 3. 1 plus 2.count. We have plus operator, but those work on lists as well. So get me a list of one integer and a list of another integer and add them, and you get a new list with another integer. And having more than 1 here, so the plus operator, if you look it up in the FHIRPath spec, will tell you that if any of the operands on both sides is a list with more than 1 element, it's an error. So we have no special logic for sets or single instances, and this gives it the FHIRPath language a pretty fluent. You don't have to say, if this is a singleton, let's do this. If that's a list, do that. That's boring in my programming language, C#. I don't have to do this here. There's a way more monadic thing, way of looking at things, and easier. Okay. Now we have our lists. What's next? We want to compare it. We want to say, well, his first name is Ewout, so we need an equals operator there. I don't know what we're doing here. I mean, this could be extracting. Extract me all patients, extract me all names where given is Ewout. But it could also say, get me in a whole database of patients, select the patient with the given name Ewout. You can use FHIRPath in a lot of contexts, but we do need this equals operator. Of course, we have smaller than. So these are expressions returning a Boolean, and you could use them in business rules. So as in structure definition. And then these kind of expressions turn into, this structure definition says that this instance is valid if patient.name.count is smaller than 2. So certainly we're not selecting stuff anymore. We're treating these as predicates in a structure definition to validate whether something is true or not. Powerful stuff there. We have the usual operators, of course, smaller than, XOR, concat, diff, mod, whatever. And the normative edition of FHIRPath has added a few more there, as usual. But it's mostly the normative version is an extension beyond DSTO1, so there are no breaking changes. Also good to know is that we do have an if, and just like in many functional languages, if is an expression, so it returns a value. So depending on whether patient.name exists, I will return the string yes, or I will string no. Depending on your language background, again, this feels totally normal, but if you're imperative, that is not normally the case. Everything is a list. Yeah, I told you so. Good. So that's interesting, because name.given, given repeats. So that's a list, and I'm comparing it to a constant Ewout. And that one is even worse. Name could repeat. So we could have lots of givens, and I'm comparing it to that. What would happen here? What would happen if patient.name.count is larger than 1? Anyone has an idea here? So if I have multiple names and I compare it to a single string, what will happen? Is that an error, or would it return false? Guess? Yeah. What you're doing here is you're comparing a list then with multiple elements to a list with a single element, Ewout. So it's false. They're not the same thing. You could use contains to see if one list contains the other. So that's something to be aware of. This could work for a long time until someone hands you over a bunch of data with multiple names and it starts to maybe give you something unexpected. And when you do patient.name.given and so concat patient.name.family, that's just like that plus operator. This will just error out on you. Say, you know, I need, yeah, you pass me 2 lists, one with a given and a family, but if any of those has multiple elements, that's not how I've defined to operate. In the documentation for each of these operators, it's really clear whether it works on lists or singletons or anything. And FHIRPath is typed. I mean, I have shown you integer, I've shown you string, so implicitly you felt that it was typed, but it actually is, so I'm going to show you a few more of those. These are the types that are present in FHIRPath. So booleans, I don't think I showed you before, patient.active is true, and here are the literal expressions for these types. We have time and quantity, and datetime. And that means that depending on the context where FHIRPath is used, you need to map it. The fire part of the FHIRPath specification, that's why I'm showing you this. I said if you go to the fire specification, you won't find anything about FHIRPath. That's not true. There's an appendix in the fire specification that details how FHIRPath is integrated in Fire, and that details how stuff in Fire is mapped to these types in FHIRPath. Another interesting set of operators is about, so if we're typed, we can also select on types. We can create predicates based on types. For example, observation.value. We all know that observation.value has a large list of types that it can have in an instance. So it's perfectly okay to be able to say, well, I really like to assure that observation.value is a quantity or observation is a ratio. So we have the is operator to select based on type. And there's another one. You can filter lists with the of-type function. So patient.descendants will give you anything in your instance under the root, more or less, and patient.descendants of type human name would select a human name present anywhere in that whole tree. I don't know whether that's useful, but you can do it. So it filters a collection on items of a given type. It's actually useful in one place I know of. Give me a whole instance and filter on all the descendants that are references. That's really useful because once you got the references, you can, if they're relative, you can rebase them on your server's base address or whatever. So filtering descendants on a type actually has a use. So never say something is useless. It's definitely useful on things other than descendants, but yeah. So we know how to navigate down a tree. By name, first, last, and so on. We got a little bit smarter on types, but that's not all. Any language, any selection language that we know of, like whether it's anything that has flower expressions like xQuery or .NET Link, has filtering and projections operations, and FHIRPath has them too. So filtering first. Yes, walking through a tree by name is nice, but it would be nice to do smarter things like this. Patient.name, where use is official. And this will not, so what it will select is go over patient.name one by one and then select the names with that characteristic use is official. So this red box is one of the uses that matches that statement, of course, but what you're selecting is not the use, what you're selecting is the name. That's important. No, that's a common trap to fall into. So this allows you to select a name or any node in the tree based on stuff that happens under it, or whatever expression you can do there. You can select names if they have more than 5 children. You can, whatever you make up, anything goes there. After the where here, you can put any kind of FHIRPath expression there. So that's a smart filtering there. And then we can do mapping. Sometimes you want to rewrite your results, like a select statement in, I think in LINQ, a select statement in SQL. Sometimes it's called map in other languages. That's the same thing here. So patient.name.select. And what do you want me to select? Go over name. Probably have the text here too. Yeah. So go over the name, go over all the patient.names. And for each name, run that bit of code, that FHIRPath code. So for each name, get given in family, concatenate them with the space in between, and return it. So obviously, if name has multiple items, the output is multiple items. If this is my input, then that is my output. Now note that we no longer are in FHIR domain. Here we started out with patients, and now we have lists of strings. So the output of FHIRPath is not necessarily again something that is FHIR. You know, if you ended this with a dot count, it returns the FHIRPath evaluator would return you a 4, which is no longer FHIR. So you can take FHIR as input here and output something entirely different. What happens if there's more? There we go again. What happens? I mean, we say everything is a list. Yeah, but what happens when there is more than one given family for one of these names? Is that an error? So I get a name, and it has multiple givens and multiple families. So for each of these names, we would run that expression, and that ampersand there, that concatenation expression, would receive multiple givens, and it's defined to work only on, you know, an operand with 1, so this would be an error. Great. So far so good? We're going to treat something that is a little bit more nasty. In the first versions of FHIRPath, this was more or less the state of things. And then people started to saying, this is such a cool language, you like to use it for a broad domain of things, but there's one thing really missing. You're not dealing well with missing data. And we were like, how so? Well, what happens if I say patient name dot given and then concatenate it to something else, but there is no given in this instance? We were like, yeah, well, we don't know. And so we had to really rethink FHIR. So before we went to DSU1, we had to rethink FHIR and think how to deal with missing data. So that's worth spending some minutes on. So here's the problem. Patient.name.given is duck. What does this do if given here, if there's no given at all? Is this true? Is this false? The only reasonable answer, and well, I really didn't want to go there, but that was the conclusion, is it's none of the above. It's empty. If you don't know, if you don't have givens and you compare it to duck, then the result is, I don't know. It's missing. I can't compare it to duck. I don't know what the equals operation result is if one of the two is missing. So missing equals duck evaluates to missing. Missing is larger than 1, I don't know. The data is missing. What can I tell you? So the result is missing again. And now the most confusing one, but this is the same in other languages that had these 3-valued Boolean logic. Missing equals missing is also missing. So we propagate, as we say, we propagate missing over the operators. Adding missing to 2 is missing. Anything you do with missing propagates missing. And we have that in SQL, so if you're used to it, you know, that's your world. But I personally had to really get used to it, and we all did. We had to rewrite all the invariants in the FHIR specification just because of this. So we were really thankful for this guy to show up. But I think it's got a better language because of that. And that means that our tables, for example, the OR operation here, they have another column called empty. So it's not always true that you need to return empty. if one of the arguments is true, and the other, well, this is a simple OR. It only gets interesting, well, here on the right-hand side. So if I get true or empty, I really don't care about it. I don't know about the data, because the OR operation is true if any of two operands is true. So true and empty, or empty, is true, because I know enough. The first argument was true, so I don't care about that the second one is empty. False, the same thing, and of course, well, empty, and so on. So we had to redefine OR and AND on all these operations in these three-state logic. Well, we didn't have to. You just look it up on Wikipedia. A lot of people have been thought about that before. Though interestingly, that there's different schools of thought, like whether missing data implying other data is actually something you can say about, and there's different schools of thought, but we just chose one. Luckily, some operators allow you to deal with unknowns, because you don't always want to return. If you say, oh, but I don't want missing plus 4 to return missing. If I have missing data, I want to do something else. Okay, that's fine. We have a few functions to deal with those. So we have, for example, the all function. Patient.name all given is doc. That doesn't really care whether given is empty or not. It returns you. So if name is empty, this still returns true. Because if I don't know anything, are all names doc? Well, we've defined it to be true, and that's the way the logic people said this should work. If any given is empty or given is not doc, it returns false. Yeah, because if any given is empty, then they're not all doc, so that kind of makes sense. Well, so where given is doc, only include patient.name where the expression given is doc is true, and the empties are left out. So if you have a name with a given that without a given, it is not returned. And finally, we have the exists operation that tests whether something is missing or not. So given.null exists. Okay, if it exists, then that implies patient.name.given is doc. That's actually how I should have rewritten. If I want to test whether my name is something, my name is Ewout, and I don't want it to return, I want it to return always to return true or false, you have to use the implies function. So if given that 0 exists, that means it's doc. If it doesn't exist, then it's false already. You don't have to go on. So this way, we can turn these empties into actual true-false statements. So the implies function is really important when you start dealing here with empty data. Anyway. The best thing to learn about this is to go over some examples. I always say that. I mean, XPath, it was certainly true. But with FHIRPath, just to get a hang of what can I do with this language, there's lots of examples, because almost every resource in the FHIR specification has a set of constraints, and all these constraints are formulated in FHIRPath. So if you want to look up some great examples, all you have to do is open up the spec and look at a few. So inspiration from the spec, definitely. So for example, if you go to value set here, every resource you will find this section called constraints. And that has a whole list of constraints that are formulated in FHIRPath. There we go. If mode is fixed, then a code must be provided. See, that's the missing thing here. That's how we deal with missing. So if one field is something that implies that code exists. That's how you would formulate that. What I did for you is I selected a few of the most common things that you'd like to do in these cases. So these are really worth looking at. Types must be unique by the combination of code and profile. We have a distinct function that does that. So, but many times you run distinct on a single field, but what if you want to have a combination distinct? Well, you can use the ampersand concatenation operation. So type has two elements, code and profile. Well, it actually has a third one called target profile, but anyway, type.select, code and profile, and that needs to be distinct. So that's, now I know that the combination is distinct. Actually, the third bullet is interesting. Enable when is from questionnaire. Questionnaire is heavily used. FHIRPath is heavily used in questionnaires to dynamically enable fields depending on what answers you supply to previous questions. So enable when, which is used in questionnaire, must contain either an answer or has answer element. So has answer exists or answer exists, but not both. So somewhere else you had an answer, and so the XOR operator is if you either instead of or. Best thing to do here, of course, is to try this out. And luckily now, this is not science fiction. We have quite a few implementations of libraries that implement FHIRPath. Nikolai has written a JavaScript one. Of course, there is a Java and a Pascal one. Pascal one because Graham uses Pascal. Delphi, I must say. I think it's Delphi, rather. This is from that page. I didn't write this myself, but it's incorrect here. Title FHIRPath implementations. For Graham's server, of course, it's there. For Java and so also for Happy, there's a FHIRPath engine. And I wrote one for .NET. But these are all libraries. So you can test them out by including them in your software. But there's also some tools, some end-user tools that you can use to try it out, like Notepad++. The Fire plugin for Notepad++, I think that's using the Delphi one. And then Brian Postlethwaite has written a FHIRPath tester based on my .NET FHIRPath engine. And so you can download that on GitHub from there. And then it's used in CQL to Elm. So CQL is one of those, clinical quality language is one of those other standards that actually use FHIRPath, and the guy behind this, Bryn Rhodes, has been, a great contributor to the FHIR spec, and he has brought us into the wonderful world of tri-state booleans. That gives me another 5 minutes for questions. So, are there any questions?
Yeah, just the example page. You have one with the distinct combination. Oh, sorry.
Oh, we have a mic.
Yeah.
Otherwise, I would have repeated your question, but this is even better.
You have a question with the distinctness of combination of code and profile. So I was just wondering, like if there are multiple codes, or could maybe figure it out, but it will fail, right? Yeah. If
in this case, code cannot repeat, so I know that. But if you want to be fail-safe, so if you want to be explicit, which is actually nice, if you know that code here is a singleton, there is a FHIRPath version .single, which will actually say, right, give me the single thing there, and otherwise fail immediately without some kind of, without even invoking the ampersand operation. Or you could say code.first and be sure that it, well, sure, no, but code doesn't repeat, so this would work. But otherwise, that's an error. That's correct. Yes?
Can you provide some insight into why you chose to have the operators operate only on singletons and not function like a cross join, and how you would do a cross join with like plus or something like that?
I don't think we could do cross joins, could we? Cool. What kind of use case are you thinking of, for example?
I don't have one. I just wanted to.
Oh, you just
wanted to know.
So cross join. Let me see. Well, actually, we can do cross joins, because what I didn't show you is that there is. Cross joins. It depends. If you want to join some data, some list on a list that's in a different resource, there's no way to do that in FHIRPath. We're always operating on the same instance. If you want to iterate over one list and combine that with something that's somewhere else in the same resource and join those two together, you could, because there's a special variable called %resource, and it's actually good that I get a chance to mention that. That allows you to actually include data from elsewhere in the same resource. So you are able to link them up then. So that's a good addition. It's actually a frequently asked question, so I should put that here. Because once you're down in a tree somewhere and you say, I want to compare this to something else somewhere else in the tree, you can navigate down again, like what I did with use, right? Select all names where use is something. But what if you want to navigate back up somewhere else? There is no parent in FHIRPath. But what we do have is the symbolic variable %resource, which will put you up in the tree again, and you can navigate down. So you can say where .resource name in another part of the tree, and then compare the two. So you can do it that way. Does that answer your question? Yeah.
I want to know what's the difference compared to the Circle, because Circle probably also can do lots of these kind of things. Why we have a separate FHIRPath?
So compared to what? I didn't really...
SQL.
Oh, SQL. Well, SQL has no... we had to... But the base SQL has no natural way to really navigate down a hierarchy, right? You always have to do joins to join a table of things. So that puts you in a world where everything is still more or less, I think, a distinct table. Where here we're dealing with trees. So we followed more XPath logic of navigating a tree rather than using SQL, where you would always be joining tables on some kind of shared something. I mean, we could have used xQuery, maybe. That would have been one possibility. But xQuery is full of statements for dealing with the difference between elements and attributes, all the things that don't make sense to it in JSON at all. And some things that we really like to do, that we often and commonly do in FHIRPath, had like these expressions in XPath. So we were by able to do this. And there was, of course, the differences in platforms. Some platforms have no support for recent versions of XPath, so we couldn't really depend on that. So that's why we didn't choose XPath, and that's why we didn't choose SQL. Yeah?
When you were doing a .select, does that always return sort of a JSON format?
So
I think you put up, I saw an example where there was a little bit of output from a
there is a select example there, but you meant one that was here at select, I guess. Yeah. This one?
So is the output from that? So could you get could you use that to build a chunk of JSON? Is that kind of like the idea behind that?
So the example here is in JSON. The thing is, of course, that FHIRPath navigates over this abstract model. So what's the output? So it's a good question. If my input is JSON or XML, and and then I turn this into this tree, and then I select a subtree, what's the output? It depends a little bit on the API you are using, but some APIs will return you. For my API, for example, returns you that abstract tree. I have put that abstract tree really into interfaces in the library, so that's what you get back. And if you then want to turn it into JSON, you just serialize that to JSON again. So it's definitely taking you out of XML or JSON, selecting things on this more abstract model, and then you can, by serializing, turning it back into JSON or XML. But it's not returning you JSON or XML, because FHIRPath doesn't really run on JSON or XML. Tomorrow we could add another syntax there. So it's. Do I have time for more?
So there's nothing after this, so we can afford to go a bit over time.
Until the questions start to be really boring. Okay, let's go. Is there another question? I hear the yes, but I don't see, no? Good. Well, in that case, let's have coffee. Thank you.